Hey guys, in this video I'm gonna quickly explain how to add these vectors. If you recall, to add vectors we first have to decompose the vector in its components, so let's do that first. To get the x component of the vector a, we just multiply 150, the magnitude of the vector, times the cosine of the angle. Okay? And this is equal to 106.1 newtons. The y component is very similarly calculated, but this time instead of the cosine we use a sine of 45, okay? And this equals actually the same number, 0.1 newtons. Let's calculate for the vector b. Okay, let's say the component x of the b vector would be equal to 200 times cosine, but in this occasion note that we have the angle from a different axis. To use this same equation we have to give the angle from the x-axis. If you recall, from the x-axis to the y-axis there's 90 degrees. From the vector b to the x-axis there's actually 90 plus 30, that's 120 degrees. You have to take into account that this direction of the angle, we're starting from the x-axis and going in a clockwise manner to our vector. This direction, we call it the negative direction of the angle. So this angle is actually minus 120 degrees. If we substitute 120 degrees and we calculate it, and we have minus 100 in x, and the y component will be calculated the same as last time with sine of minus 120. And it's equal to minus 173.2. Now we do the same for the c vector. Let's note again that this time we have the angle from the negative direction of the x-axis, and we have to have it from the positive direction of the x-axis. So it's important to calculate this angle right here. This angle will be equal to this plus this. If we recall, here we have a 90 degrees, and from here to here we will have 90 degrees as well. So 90 minus 60 will be equal to 30. The angle from here to here will just be the sum of these two, and that will be 120 degrees. Now we do the exact same substitution, and we have that c, the x component of c, will be equal to its magnitude, 200, times cosine of, this time is plus 120, because we're defining it in the positive direction of the angle, okay? Cosine of 120, and this will be equal to, let me calculate it here, 200 of 120 of minus 100, and the y component of the vector c will be equal to 200 times sine of 120. Okay, so we substitute it, and we have that it's equal to 173.2 in y. So it is very important that your angles are defined correctly. If you define your angles correctly from the x-axis and take into account if it's going in a positive or a negative direction, your components will have the correct sign. If you just make it with the angles, you will get incorrect calculations. I'm gonna write these abbreviated in a vector notation. To now calculate the resultant vector, let's say we want to find out a plus b plus c. The only thing we need to do is actually just add up the three components of the vector. So the resultant vector, let's call it r, will be equal to the addition of the three components in x in the x direction, so 1 minus 100 minus another 100, comma, in the y direction we have 106.1 minus 173.2 plus 173.2. So the x component would be 93.9 and the y component would be, oh never mind, these two cancel each other out and it's 106.1. So this is the resultant vector. If we want to plot it to give an idea where it goes, let's say it's in a positive direction of x, it has a positive direction y, resultant vector would be somewhere here, okay, in this quadrant. If we want to calculate the angle of the vector from the x-axis, this angle, theta, it is theta, this is the resultant vector. Theta would be equal to the inverse tangent, so tangent inverse of the y component divided by the x component, okay? 93.9. And it has an angle of 48.5, well, approximately 48.5. What would happen if, let's say, instead of just adding them up, this time we multiply the vector b by a factor of -2. A minus 2 times b plus c. Well, in this situation, we will have the resultant vector and we will have the first component, the number we put here will just enter the vector and multiply each of its components, okay? So -2 will be multiplied by 100. So let's write this down, 106.1, and -2 times -100 will be plus 200 minus, and c, okay, 100. And in the y direction will happen the same. We will have 106.1 of the vector a, and we'll have to multiply by -2 the y component of the vector b. Okay, so -2 times that. Well, let's not use the calculator. It is plus 346.4. And plus c, the y component of the vector c is 173. So plus 173.2. Okay, so we add this up and we will have r equals equal to 200, of course 206. 206.1 in the x direction of the r vector, the resultant vector, I'm sorry. So let's call this r2 to differentiate it from the first vector. Okay, and we will have a 625.7. Okay, if we want to have an idea, we can see that this resultant vector will go in the first quadrant of our coordinate system. Now, if you want to find out the angle, this vector will go very steeply. It has a 625.7. If we want to find this angle, let's call it theta sub 2. We can use the same equation. Okay, so it's theta 2 equals the inverse tangent of 625.7 divided by 206.1 equal to 71.8 degrees. So this is how we add and subtract vectors. To make somewhat of a summary, just remember, a vector has to be broken down into components, and then you simply add each component of the vectors. And if there's a scalar quantity multiplying it, you just multiply each component of the vector. If we want to find the angle, we use the equation that says that the inverse tangent of the y component divided by the x component is equal to the angle itself. If we want to find the magnitude, we write it like this. This is the magnitude of the vector. We can as well write it just without the vector sign up top. And this is equal to the square root of each of the components of the angles. In this case, we have 206.1 to the square plus 625.7 squared as well. And this will give us a magnitude of 658.8. This is the magnitude of the resultant vector. So hey guys, thank you for watching. If you liked the video, please hit the like button and maybe consider subscribing. Thank you very much.